Students, can you able to hear?
Yes, sir.
Okay, good. Yeah. Yeah. I started the recording. Okay. So we are meeting after a week break, right? So all your exams are over now? Mid semester. Hello? Hello?
Yes, sir.
Yeah. Is your exams over? All of them?
Yes, sir.
Okay, good.
So some of them like they like rescheduled so that we can like get some more time. Most of them are over.
Okay, good. Yeah, right. Okay. So, yeah. Okay, let me share the presentation. Okay. Okay, so is this slide visible? Operating system structure and all.
Yes, sir.
Okay. So, so let me recap. So, in the last two lectures, actually, we are discussing about the operating system. So, as you are aware of this by this time, so the operating system will basically play an intermediary role between a computer. It's nothing but the basic hardware and the user or the application programs. So that we have seen. Because the bare hardware will be very difficult to handle or to be used by the users, the application users or application programs directly. We have seen that in the when you are discussing about architecture. So how delicate and how like a primitive it is, and also we seen that. So therefore, basically the operating system will play a role that where it provides the nice interface and the convenient environment for the users and application programs to make use of the hardware for its execution and application and all. So that way, in the last class we discussed about the basic components of a computer that we have seen at a very gross level, because we already come across in the in the previous lectures already, and we have also seen that how these components will interact with each other. So in that, how the operating system will play a role and all, what is its role, how it coordinates the communication between the different components. So those aspects we discussed very briefly. And today we'll try to discuss about because as you know that in a computer, the application programs or user programs will run, and then to run the user programs, the even the operating system also will help, or operating system programs also will run to coordinate the execution of the user programs and all. So therefore, we'll see that today how these the coordination will take place, how these both the programs like user programs and as well as the operating system is nothing but they're also a piece of code, right? So these codes how they run, both user programs and operating system codes and all. So and then what are the basic functionalities of operating system? So in view of coordinating the various user programs and the various resources and all. So all those things we'll try to discuss very briefly. And so most of the things whatever today and the next two lectures whatever we'll discuss. So this is mostly the introductory part of the operating systems, which gives you the broader picture or broader view of an operating system, like what are its various functionalities, how they are executing, how they are performed, and suppose for performing all these things, how do you design the operating system and all, right? So what are the various environments where the various computing environments will be there? So in that case, how the operating system goals or objectives will differ. So all these things we'll discuss very briefly. And so as you go on, you can come to know that most of these things kind of a reading material. So I will just try to go through that at a very superficial manner and all. so that you just come to know about like at a broader picture about the operating system. And anyway, later on, after that, we will try to discuss about each of the components or each piece of that in a more detailed way. Like in case of, for example, for effective utilization of CPU time on CPU and all, how what is the role of operating system, how it will perform, what are the various scheduling algorithms. All those things we will discuss very detailed later on, right? So, and these lectures and all basically like they give you the overall perspective or a broader perspective of operating system, and afterwards we'll go into the specifics of each of them. And so here, like in the context of the multi-programming or multitasking environment, as you know that, for example, if you want to run a single program by over a system and all, so it will not effectively utilize the resources and all. That means we cannot make the CPU and all IO devices will be busy all the times and all, right? Suppose when it requires the CPU, then the IO devices will be free, or otherwise when it requires the IO activity, at that time the CPU will be idle. CPU is waiting for completion of IO. So likewise, a single user cannot keep the both CPU and other resources will be busy all the times. So that's where you can use the concept of multi-programming. It means that multiple jobs will be loaded into a memory, and then a particular job will be executing by the CPU. And then at some point of a time, it requires the IO activity, for example, that means it requires some input and all. At that time, that particular job will be switched from the CPU, and it will be given the access to the IO and all. In the meantime, the CPU can handle some other job, some other program and all. So likewise, by the multiple programming will enhance or will try to make use of the resources effectively. It tries to keep the resources will be busy. Like for example, the CPU to be busy all the time. Like CPU may be executing job one, and at some point of a time, the job one requires some file access or something. So at that time, you need to it needs some time. That means that particular time because the file has to be fetched, or it takes some time. So in the meantime, the CPU will be given access to the job 2, and it executes the job 2. Then whenever this file completion is done, then again the job 1 will be placed. So that way, by keeping a multiple programs in a memory, and we can able to switch these programs over the CPU based on the IO requirements of individual jobs and all. So that way, this multi-programming is basically tries to make the keep the CPU to be busy the most of the time and all. Right, so that way the OS switches the jobs between the jobs and all. Whenever a particular job needs some IO, then some other job will be placed onto the CPU so that the CPU will be busy all the time. So this is a simple multi-programming concept where in this case actually here, as long as the job requires to process by CPU, it can make use of that. So mostly here in this, the multi-programming here in this context will be the jobs or the programs that are running or considering over here are the non-interactive jobs or non-interactive processes or programs and all. Like for example, mostly like mathematical some, for example, in case of any particular organization, just computing some the employees some details and all, like their salaries or something. So if you have data, if you provide proper data to that, then each job will be run on its own, and it's not much user interaction is required. And whereas there are some other applications where it requires a lot of user interaction or a lot of interaction is required from time to time while the program is executing and all. So in that case, actually here, we need to switch the jobs to the CPUs very frequently and all. Whereas earlier and all, the CPU will switch the jobs, or the job will be switched from the CPU only whenever it requires the IO. That means if it requires the IO, then at that time the job will be switched and then some other job will be given to the CPU. So likewise, the jobs will be switched from CPU whenever they need the IO other than the CPU. And here in case of multitasking or known to be time sharing approach and all, where in this case here we are assuming that here the applications or the programs requires the user interaction from time to time during its execution and all. Right. So in that case, actually the jobs or the programs, whatever, so they will be switched from time to time. That means they will be given some time slot like order of milliseconds or microseconds and so on. So likewise, each job will be given or each program will be given a fixed time slot of, for example, some 10 milliseconds, for example. So when a job is given to the CPU, it gives a time slot of 10 milliseconds. So during that time, if it requires the complete CPU for an entire 10 milliseconds, then it will make use of that. Then at the end of 10th millisecond, then the job will be taken out and some other job will be given because the time slot that was given to be 10 milliseconds. And sometimes during this 10 milliseconds itself, a program needs some IO. So at that time, the program will be again switched from the CPU because it requires IO in between. So therefore, it will be switched from the CPU and the CPU has been given to the new job and all. So these here in this case, what I'm saying here is that in case of time sharing, the jobs or the programs are mostly the interactive jobs. Like for example, now when you're doing a word processor and all, like for example, you can see that. So whatever typing, you can also see the characters, whatever it's printing and all, right? So these are the kind of mostly the interactive things. That means we are pressing one character and then the program will take that character into that and then it will try to display that. It's like mostly the interactive jobs, interactive applications and all. So for all these cases, interactive applications, mostly the CPU will be execute the jobs in a time shared manner and all. That means a time slot will be given that depends upon the nature of the applications. The time slot varies and all. So that way there are known to be the interactive computing. And here the response time will be usually less than a second will be there. And each user will be at least one program is to run. And again, the program that is running, executing is going to be process. We'll see that what is the difference between a process and a program bit later and all. And then there will be several jobs ready to execute at the same time. So in that case, actually, so which job has to be given to the CPU and all. So that will be done by using appropriate CPU scheduling methods and all. That depends upon the priorities. And sometimes no, it will be simply like first come first served basis. There are different strategies are there. So with that, the jobs can be given to the CPU like one or the other and all. And sometimes the process may not be fit into the memory. As I mentioned, there will be programs which are very large, and they cannot be accommodated into the main memory at a time, right? So in that case, we can use the techniques known to be swapping and all. So with that, actually, a finite amount of a program, a small piece of a program will be placed into main memory. And afterwards, once its execution is completed, then it will be placed into the main secondary, and then again another segment will be brought into. So that way, using the concept of swapping and all, we can run the programs which may not be fit into a main memory, right? Which is larger than a main memory, can also be run, can be executed by the CPU. For that, actually, we will make use of a concept of not virtual memory. We discussed about that, right? So by using a virtual memory, it can able to support the process or programs which are in a larger size, which cannot be completely accommodated or cannot be kept in the main memory and all, right? So yeah, that way here, all these things and some or other way, the operating system will involve in carrying out the various tasks of this, like either for a multi-programming or for these multitasking environments and all. So like the operating system will be involved in carrying out various activities and all. So anyway, this way they can to perform this multi-programming, the multiple jobs will be placed into a memory, and then one after another, the jobs will be given to the CPU for its execution and all. And the another one is that actually here the operating system is nothing but a program, a piece of code, or a collection of programs and all. And here the operating system will be will come into the picture, its execution, that depending upon interrupt and all. That means whenever some event occurred, or whenever there is a need of operating system to be run, so that is nothing but that is indicated by some event will occur, and against to that interrupt, against to that event, the specific operating system code or specific OS routine, OS service routine will be executed and all. So mostly the OS will be coming to the execution due to the interrupts. So therefore, you can call it as interrupt-driven execution, and it may be the interrupts may be driven either through hardware or software. Hardware means suppose a device requires some service and all. At that time, the device will interrupt the CPU, and with that, a corresponding operating system service routine will execute, and with that, whatever the device service that is required, that will be executed and all. That means the device up to that point, it captured some data and all, it want to deliver, it want to place it into the memory and all. Then the device will be informed to the system by sending a signal and all. Then the operating system will realize that will try to see that the device needs a service, and then it performs the desired service and all. And likewise, sometimes the software also requires the operating system service and all. So software means suppose you are running a user program and all. So in that user program, when you are running a user program, so you want to take some input. You want to capture input from the keyboard, for example, like user has to give some user input and all. So at that time, the user program will not directly access the keyboard, a keyboard interface and all. So instead, actually, it requires the OS service and all. That means the operating system has will provide the interface, will provide the interface to the keyboard. So with that, the keyboard it will communicate with the keyboard, and then whatever the desired input from the keyboard, so that will be provided by the operating system and all. So that way, that what I mean to say is that when you are running a program, the user program also requires sometimes the operating system services and all. So at that time, the operating system will provide the service to the user. One example, as I mentioned, that when you're writing, when all are familiar with the C programs or whatever other programs. When you want to take input, the user input, like whatever the size of the data or whatever. So in that case, actually, where that capturing the input from the input from the keyboard is carried out by with the help of operating system and all, because they have keyboards, hardware device and all. So therefore, to handle that, there will be specific driver and maintained by the operating system at its lower layer, and that device driver used to communicate with the device controller, and with that help, with that the desired the data input from the keyboard will be accessed and will be placed in the appropriate location to memory and all. And not only that, sometimes when the program is executing and during its computation, sometimes sometimes some errors may happen. Sometimes an arithmetic instruction tries to execute a division by 0, or sometimes when it performs some addition or subtraction and all, some overflow may occur and all. So all these cases and all where if there is some error occurred, some event which is not supposed to takes place and all, if that occur, at that time also operating system will come into the picture, and its corresponding routine will be executed, right? So not only that, there are different cases, like for example, a particular program is having some infinite loop, and it almost captures the for a long time for the CPU and all. At that time, there are a lot of pending jobs they are waiting for CPU access and all. So at that time also, to control such things also, the operating system will come into the picture in the form of by using a timer interrupt and all. The operating system will stop the execution of the currently executing program and provides access to the other programs and all. So likewise, mostly the operating system code will be executed with respect to the interrupts, either by the interrupts may be initiated by the hardware or due to the software and all. And so, as I already mentioned, that the system on the system, the user programs will run, and along with the user program to run the execute the user programs efficiently and provide the desired services and all. Time to time, an operating system also will take over. Operating system programs also will run. Operating system code also will run on behalf of the user program. Like as I mentioned, example the user programs requires to capture the input from a keyboard, for example. So at that time, actually here the operating system will take over, and the operating system will perform the service on behalf of for the given user program and all. And for carrying out these the operating system services and at the same time user programs also will run. So we'll make use of a dual mode of operation. It means that the system will operate in two different modes. And so one mode is the known to be user mode, where in this mode, the user programs are user instructions or application program instructions will be executed. And there is another mode known to be kernel mode. So here in the kernel mode, only the operating system code or operating system routines will be executed. It's known to be kernel mode and all. And the distinction is that the user mode is nothing but here the user programs, whatever the application programs we write, and those programs will be executed in the user mode and all. And kernel mode means the system programs, basically operating system codes. So they will execute in the kernel mode. So why this distinction and all? Because actually there are certain instructions known to be privileged instructions and all, and those instructions should be executed only in the kernel mode, only in the kernel mode. Because for example, as I mentioned, like for example, you have a drivers and you want to set some bits in the driver control, some device controller and all. So at that time, accessing the device controllers or interacting with the device controllers and all, the user programs cannot be done because we don't give access to that. The reason is that if you give a user programs to access to all the resources and all the other components and all, sometimes the protection or security will be the issues and all. That means the user program may wantedly perform some malfunction and all can be done, and may want to disturb the other programs, the memory or whatever other things also. So therefore, to avoid that, actually the execution of programs will be carried out in two different modes, known to be user mode and a kernel mode and all. And the kernel mode will execute the privileged instructions. As I mentioned, for example, if you want to set some bits or if you want to set some registers or if you want to interact with certain device controllers or other things, so they will be done only in the kernel mode. Only those instructions will be executed, has to be executed only in the kernel mode. They cannot execute in the they cannot be executed in the normal user mode. And this mode bit will be like provided by the hardware, and these mode bit will be set or again the reset by the system calls and all. It means that suppose whenever the user program, assuming that the user program is running, so in that case the mode bit will be like 1, that is indicating that the user program is running and all. And for example, at certain point of a time, the user program requires the this one to take the input from a keyboard, for example. At that time, the user program will call the like operating system. So at that time, the switching from the user mode to kernel mode, it will be carried out in the process of calling a system call. At that time, the system call, while initiating the system call, there will be a trap instruction will be executed, and the trap instruction will set the mode bit. That means here the mode bit will be earlier it will be 1. Now it will be set to 0. So the moment the mode bit is set to 0, then at that time from that point onwards, the operating system will take over and the corresponding system calls and all those things will be executed. And at the end of the system call, once the system call is completed and it's about to return to the user program, at that time, the system call again will set the mode bit to 0 to 1, because assuming that mode bit is 1, indicating that the user mode, and mode bit 0 indicates that the system mode and all, system mode or kernel mode. So that way, these mode bit will be operated by system call. Let me system call changes the mode bit from kernel to the user or user to the kernel mode and all. And usually, in general, there are two bits. That's a dual mode of operation: user mode and kernel mode. And now, in the recent past, where as the systems have been used extensively in a different aspects, like using the virtualization and other things, where we are using like more than 2 bits, more than 2 modes of operation, known to be multi-mode operation. So here we are introducing one more mode where suppose when you are using the machine in the virtual mode for running certain program by using some other operating system, for example. So at that time we use the virtualization concept, and at that time this virtual mode, that means when this particular virtual machine manager, if this is operating, this particular code is running, at that time we make use of the another mode, like it's not neither user mode nor kernel mode. It's in somewhere some other intermediate mode, some other mode. So that in that mode the system will operate, and that is indicating the virtual mode or running a virtual machines or something like that. So normal case, if there is no virtualization and all, these 2 modes are good enough, like user mode and kernel mode. And suppose if you want to use the machine, or if you want to use the system in a virtual, or if you want to do some virtualization, or using a machine for as a virtual machine, like performing giving access to the multiple users, where the users can run on multiple on a different operating system on its desired operating system. At that time, using a virtualization, you can able to perform that one. So whenever the virtualization or like virtual machine manager, if this is operating, at that time we'll use another specific mode, and that way at that time instead of two modes, we'll go for a third mode also, right? So we'll see that later. The later slides you can see what is virtual machines and all. And here this is the just illustration that you have user program, and if it requires any operating system service and all at that time, so user mode bit will be 1. So whenever the user programming is done, and then the mode bit will be 1. And whenever it requires the service of operating system, at that time the operating system code has to be run. So at that time it will the trap instruction will set the mode bit to 0, and then the system call will be executed. And at the end of system call execution, that is just before returning, that means because the last statement of the system call will be the return address. Just before that, the mode bit will be again reset to 1, because it's about to enter into again the user program. So therefore, it will be mode bit will be set to 1, and then it returns. That means then the desired user program where it has from a specific instruction where it called the system call, and again goes back and then return to that particular instruction where it called the system call, right? At that time, because again from that point onwards the user program starts, so therefore the mode bit will be again set to 1. So that way, usually the operating system and these user programs, they will run in a dual mode, and whenever the operating system runs, it will be run in the kernel mode, where mode bit 0. And whenever the user programs are running, it's mode bit 1. So this will ensure the protection also, because as I mentioned that there are certain privileged instructions where the operating system only can make use of those instructions, can only execute those instructions and all. So that way, so like all these things like handling the page tables and initiating different registers. So all of them will be done by the operating system and done, so that it ensures the protection of protecting the other user programs while executing by some other user program. Yeah, timer interrupt, as we already mentioned, and there is nothing, no other explanation is required. Basically, timer interrupt is that, as I mentioned, like when if a program is somehow is there in the infinite loop and all, so then it won't leave the CPU at all. So therefore, in that case, actually, suppose if you run the systems in the interactive environment, so therefore at that time we'll make use of a timer. It's a hardware, right? And then we'll set the timer whenever for every program before assigning to the CPU. We'll set the timer for a specific time interval, and then the program will be assigned to the CPU. And now that particular timer will count down. That means with respect to the clock, physical clock, the time will be decremented. And whenever the set time reaches to 0, at that time, the timer will signals. That means timer will send a signal to the CPU in the form of interrupt. And then the CPU will realize that interrupt, and then operating system will take over. And then the operating system will switch the jobs. Whatever the currently executing job and all, its status will be saved. And then as per the next job, whatever needs to be handled by the CPU, it will be given access to the CPU, right? So that way the timer will be used for like preventing the like a kind of a job which is in the infinite loop and all. And these are the various things like the various functionalities or services provided by the operating system. And one is the process management. Process is nothing but, as we already mentioned, like even in the architecture also when you're discussing, the distinction between a process and a program we discussed and all, right? So, so we know that a process is an active entity. It means that a process, when a program is a passive entity. It means that a program or executable program, it is, if it is in the secondary memory disk, it's just a piece of code or sequence of instructions and all in a machine language or a machine code. And if you want to execute that program, that means when you try to click the run the program, it means that that program will be brought into the main memory, and then it will be given access to the CPU and all. So whenever it brought into the memory and giving access to the CPU and providing the other files to be connected, so then it becomes an active entity and all. That means the program becomes a process, and now it is an executable entity, and it will be given some time slot to CPU and the whatever IO devices that are required that will be connected and files, so that then it becomes an active entity and all. And now here to manage the process, because memory contains the multiple process, multiple programs. There's nothing but which are active, multiple process. So to manage this process and all, we have the CPU has to perform the various things. Like for example, you can say that yeah, these things, the process needs these resources and all. All these resources have to be allocated by the operating system and all, and also initializing data. All these things will be done by the operating system, right? And then the process termination, when the process reaches to a last statement of its execution, at that time, by that time, after its execution, that means the process is terminated. So immediately the operating system, whatever the earlier allocated resources to that process will be, again, it will be regained and it will be kept, its status will be changed to the other idle and all, so that these resources can be used for, can be allocated to some other process and all. And likewise, these are the various activities where related to the process and all will be managed by the operating system. Like, and as you know that a process means a program, a process means an active entity. A process may have multiple execution sequences. A process may have multiple execution sequences. That means suppose if you write a program in a very modular way, right? Even though the program may have a single program, but if you write the program in a very systematic way, having with appropriate functions where the functions are independent, in that case you can able to run the program. You can say that a program can be run in the multiple sequences, multiple execution sequences are possible, right? And each execution sequence will be known as a thread and all. So likewise, even though the program may be single program, but within the program you can have a facility to run a multiple sequences, multiple instructions simultaneously and all, right? So in that case, for every execution sequence to maintain that, to execute that, you have a specific program counter is required. Suppose a program contains a single execution sequence, then one program counter is sufficient to manage that. Suppose a program is a multi-threaded one, it means that suppose it has a multiple execution sequences are possible. So in that case, if we want to activate all of them, if you want to run all of them simultaneously, you need to have multiple program counters are required. And again, creating them and managing them, all of them is the job of the operating system and all. So all these are part of the like a process management and all, right? And yeah, these things like here you can just go through that all of them, like concurrent by multiple, like as I mentioned, like you can see that the operating system, both the CPU process and you can suppose, for example, in case of multi-processor system, we have multiple CPUs will be there, right? And we have multiple programs are there, and you need to coordinate these things. Like you need to multiplex the CPUs as well as the programs also can be done, right? Suppose we have a quad core system. It means we have 4 processors will be there, 4 cores are there. It means that in principle, you can able to run these 4, you can able to run the 4 programs or 4 instructions simultaneously on the 4 cores, one by one, one after one to each of the core and all. So there, in that case, multiplexing these CPUs or multiplexing the programs over the CPUs. So all these things come under the process management and all. So these things will be carried out by the operating system. Anyway, we'll discuss these things later in the separate chapter where we'll discuss about. And these are various process management activities, like creating a process, deleting a process. Creating a process means, like suppose for example, you want to run the program, for example, and the moment you are initiating for running the program, at that time you are creating a process. That means you are before that it's an executable program sitting on the disk and all. Now if you want to run on that, if you want to run the execute that program, means that means you are by using appropriate command or by using the mouse, you are double click on that. So it becomes a process center. That means you load that into a memory and then the resources will be allocated to that. It becomes a process. It's nothing but creating a process and all. And deleting the process. Deleting a process means like a process can come to a natural termination, and at that time you have to delete the process. And not only that, sometimes the process will be like when it's the execution at that time, it makes some errors and all. Like some errors will be will happen during its execution. At that time, a process may be deleted. That's known to be like abnormal termination and all, like aborting the process and all. So likewise, they are suspending a process, resuming a process. Suspending a process means your process is running, and sometimes now because of timer interrupt or some other event occurs, then you have to suspend the given process, and then afterwards again you have to resume that. Likewise, the process synchronization is required, right? There will be maybe you have multiple process, and there should be a kind of synchronization is required. We'll see that like where the because the thing is that suppose you have multiple process which are acting on which needs a same data item from the database, for example. Then when you are using the data by a multiple process, then these process should follow something kind of a synchronization and all, right? Otherwise, there will be data inconsistency problems will be there. So therefore, the process should coordinate and should have a kind of synchronization is required when you're accessing a specific parts of a code. Likewise, the process communication is required, right? That means to carry out a process synchronization and for other tasks also, a process communication is required. Suppose you want to send some data and some other process want to receive that. To have that, there should have some kind of a process communication is required. And again, we need to have mechanisms to handle the deadlock. As we know that a computer contains a limited number of resources, and we are running a multiple programs, and each program requires certain resources and all. So in that case, you cannot allocate, you cannot satisfy all the process and all. Sometimes it may leads to some kind of a deadlock. A process holds certain resource and it requires some other resource and all. And that other resource is owned by some other program and all, some other process. And again, that requires some other one. So likewise, each process holds something and it will not release until it gets the next one, right? So that way, even though the resources are available, but you are not in a state to utilize them, and that's not to be deadlock. So like how to handle those things, all these things are come under the process management. We'll discuss each of them. We'll discuss very detailed in a later in the part of the course, like a process synchronization, process communication, deadlocks, and like how to create a process and how to terminate a process. Like all these things we'll try to discuss very detailed way. Likewise, the memory management and all. So this memory management, I'm not going to discuss detailed one because anyway we'll discuss later. And also recently we discussed about the memory hierarchy. In that also we discussed the most of the details whatever mentioned over here and all. Memory management means basically, as we know, like in case of multi-programming, so multiple programs will be brought into memory. They have to be allocated into the memory space, specific space and all. So basically the operating system will take care of that one. And in that actually it's the operating system to handle all these issues like which part of the memory has been given to which process, what is the, how many processes are there and which of them are occupying what amount of memory and all. So so that way all these things will be handled by the operating system and all. And these are the various things like, for example, if you want to bring some new thing into the some new pages or new data into the memory, and the memory is full, then in that case, actually, what is the replacement policy? So all these things are like a part of the operating system, like come under the memory management and all, like allocating, delocating memory space and all these things. You can see that. And then the storage management. Here the memory management means it deals with the main memory. I mean the main memory, like where the CPU can able to access this particular memory. Storage management means actually this deals with all the most of the other IO devices and all. Like as you see that we have different devices where with which you can able to access the data. That may be like one of them will be the mostly the secondary memory. It's not to be hard disk. And not only that, there are other input devices like USBs and CDs, DVDs, right? And flash drives. There are many things. There are so many other devices for there. And the CPU or the main memory requires the data from all these devices and all. But you see that the nature of the devices are different. So therefore, actually the operating system will provide a logical, uniform logical view for the information storage on these various devices, various types of devices and all. Like the devices may be the CD or it may be USB or it may be some other device, but the data, whatever is the way of the data will be organized or represented on the device in a very logical way, in a very uniform way and all. So that abstract representation of the data across these devices is known to be a file and all. Right, right. So we know the file. So using the file data structure and all. So with that, actually, we can able to store the information in these various storage devices and all, whether it may be a disk drive or it may be a magnetic tape or it may be some other DVD or some other device and all. So for us, for the user, it will be like all of them appears to be like a uniform way where the information is stored in the form of a files, and then you can able to access the data in the form of by retrieving the files by accessing the files. So with that, you can able to access the data and all. So this is a very important concept of file and all. It's an abstract representation of data, irrespective of the device nature and all, right? And here, how these, with respect to that, the operating system's role is that actually how to create the file and how to manage those files and all. So all these things will be part of the operating system or file system management. Under that, we'll try to discuss about what are its responsibilities and objectives and so on. Like creating, deleting the files, directories and all, then manipulating the files and mapping the files onto secondary storage, and sometimes requires the backups and all as and when required and all. So all these things are the jobs of the operating system with respect to the storage management. And this is also part of that, just extension to that one. So far earlier, the storage management, we just thought of like mainly the hard disk and all. There will be like a ternary storages will be there, like beyond the hard disk, like magnetic tapes or these removable devices and all, like DVDs and all these things and all. So these are known to be ternary storage devices and all. And here also there will be a kind of sometimes the operating system will, yeah, here whatever it may be, as I mentioned that it provides a uniform logical view, like the data is stored either in the DVD or in the USB or in the magnetic tape and all. For all of them, it provides a view of like a file, and with the help of files, you can able to store them and you can able to retrieve them and you can able to access them for accessing and for storing into the main memory. You can use that one. So, and this table provides you the just an overview of various storage hierarchy, and then various other components carried like its access speed, its cost, its storage capacity, and who access the which component and all. So all these things are here given here, tabulated nicely and all. You can see, for example, there are registers. There are also storage entities, right? But here the registers are part of a processor and all. Then who manages this register and all? Usually a compiler. Compiler manages the register. We know that, right? In the when you're talking about in the chapter 2, like instruction architecture, you see that at the time of, because otherwise the user will not know about the registers, how many registers and all. It's basically the compiler we used to manage the registers and all, because users will handle the data in the form of variables and other data structures, but they are actually realized by through the will be placed in the appropriate registers by a compiler and all likewise. And the cache used to be usually managed by hardware, because the cache has to be accessed very fast. So therefore, usually the hardware used to manage the cache, like indexing and accessing the cache and all these things and all usually managed by hardware. And the remaining, all of them are accessed by, will be carried out by operating system and all, like either main memory and the secondary or ternary storage. All of them will be mostly managed by the operating system and all, like software. And likewise, each of them you can able to see these things. You can view this table. Yeah, the next one is that as you are now, we have seen that various storage devices and a hierarchy. And one important thing here is that when you are performing the multitasking or multi-programming. If it's a single program, then it's not the issue at all. But when you are in the environment of multitasking or multi-programming environments where multiple programs used to run concurrently, at that time you can see that we have a data that is available at different levels. That means the same data may present, actually the data is present at different hierarchy like hard disk, main memory, cache, registers, and so on. And here, there may be like, the data will be fetched from a hard disk, then the main memory, then right now it may be cache, it may be a register. And because of concurrency, then later on some other program want to access the data. Right here, the previous program, for example, it may be like manipulated, or it can be just modified a particular variable, for example, here in the cache, but it's not updated in the main memory. But the other program, if it access the data from this main memory, corresponds to that particular variable. And whereas the previous program has modified that, but that modification was not updated, right, in the main memory and hard disk. So if any program that accesses that particular data, it means that the program is accessing the incorrect data, right? Because that particular data was recently modified by some program, but that modification was not updated, right? So these are the issues will be there. So therefore, we need to handle those issues very effectively, very carefully. So therefore, the data consistency is very important. So it means that as far as possible, all the levels should maintain the same data. That means the same. If at all any modifications were there, all those modifications has to be percolated through all the levels and all. And yeah, and then in case of multi-processor environment, it's still difficult because multi-processor environment means we have in a computer, we have multiple processors will be there, and each processor has its own execution, right? Has its own cache memory will be there. And so in that case, again, to have a data consistency, here one more thing, we need to have cache coherency has to be maintained. That means, for example, you have a quad core system. Each core will have its own cache in the part of a processor and all. So if any processor has made any changes and all, so those changes has to be reflected across all the cache memory. If the data is present in the cache, same data is present in the cache, then it should be maintained and it should be reflected across all the caches and all, right? So it's not to be cache coherency and all. So it's also very important. So all these things will be handled by or taken care by the operating system and all, right? And yeah, and the same thing, like in case of distributed system, network system and all, where there are several systems are connected, and also in that case, the same copy of the data will be used by the multiple systems and all. So there also you need to have a kind of a consistency, or like whatever the modifications are there, those modifications should be reflected across all the places is required, very much required. Then the protection and security, this is also part of the operating system's objective. Like protection means here, you need to see the distinction between protection and security. Protection means actually here protecting the resources or the operating system or other process from a process which is in execution. What it means is, suppose a process is in execution, and the process should be limited to its own restricted resources. It means that the process has certain memory limits and all, so it should operate or it should execute the instructions only within that permissible memory limits and all. And likewise, the process should not access the operating system code. A process should not go beyond its limits and all, or go beyond the resources whichever is allotted to that. So that way, the operating system will ensure that by controlling the access of a process and users to the resources that are defined or given to the given by the operating system and all. So this is known to be protection and all. That means protecting the other process, or protecting the operating system itself from the other process and all, right? So because that cannot be done, because the process means whatever the instructions, whatever it's permissible, whatever the instructions that are part of that only has to be executed. It cannot access the other process memory content. So that so if we do that, it means that you are allowing a process to write something, to read something from other process. So it's not, it gives you the vulnerable results and all. and that means it also modify the operating system, and also therefore you need to protect these things. So that will be done by controlling the that operating system will perform a mechanism of controlling the access to various process, like that the process can able to perform activity only within its permissible constraints and all. Security means actually it's a different thing. Security means it's defense of the system against to the internal and external attacks. Internal and external attack. That's mean security. So these will be done by providing the appropriate access permissions to the files and access permissions at a different hierarchy. So that can be done by using appropriate the security, like authentication and security protocols. It can be carried out, right? It means that each user has been given a specific ID and all. So whenever the user want to access a particular file or user want to access a particular resource and all, first of all, he should be authenticated. That means whether he is a legitimate user or not, by giving a specific user ID and passwords, and also that way you can ensure the security from the internal and external attacks and all. Likewise, sometimes user ID, group ID and all. Suppose a file where it can able to access to specific groups or specific individual users and all. So that way you can able to perform like the security aspects by the operating system. Here security and protection, these two are different. Like security means actually here the security from the within and even from the outside the like the system also. You can expect the threats from that. Like protection means it's like the user process will try to access the unauthorized one, whatever it's beyond that. So that will be coming will come under the protection aspects. So see, this is about that. And then the kernel data structures means here basically kernel is nothing but a program, right? And it has to perform certain functionalities as we have mentioned so far, like process management, storage management, protection and security. Likewise, there are different things it has to carry out. To perform that, kernel has to, like the code of the kernel, or to perform these things, and the kernel will make use of certain data structures, right? That whatever we are already familiar with, that linked list and all, because it's a simple concept. Like for example, you have a particular disk is there, you have a disk was there, and there are several processes are in the memory, and a process requires the disk access or the input from the disk. If there is only one process request the disk and all, then it's clear you can directly access the disk based on that. But suppose a multiple process request the disk, right? Request the usage of the disk and all. At that time, these multiple process has to be wait for a disk access or for a disk schedule and all. So at that time, all these process will be wait in the form of like based on their arrival times. Like whenever the process requires, at that time it arrives to a particular IO device, and then these things will be placed in the form of a proper queue kind of a thing. Where here you can see that in the form of in the linked list, you can able to place the process in the proper sequence and all, right? So therefore, we can use the linked list for waiting keep the process to be weighted in the appropriate ways and all. And likewise, we have other data structure like binary search trees and all can be used, because you see that because the operating system sometimes it has to make various decisions and it has to perform various manipulations and all. At that time, suppose if it required that you need to search for a particular element and all, at that time here those files can be organized in the form of a binary search tree, and then by giving the key and all, you can able to find out where that particular file is available or the other way and all. So that way you can make use of BSDs. Likewise, the hash functions can be used. Like bitmaps, these are a very simple way of representation. Bitmap means, suppose for example, you have a resource, for example, and you have a similar resources are available, or like replicas of that 8 or 10 are available. And availability of them can be represented using bitmap. Like if they are available, then it is indicated by the status bit 1 and all. If it is not available, or if it is busy, that is indicated by 0. So a pattern of sequence of 10 bits will indicate that in that actually how many resources are available, how many are not available. So that way, using the bitmap. Likewise, what I've mentioned here is that kernel, to handle the way its programs and various other things and all, it make use of data structures which are already familiar and all. We'll come across these various data structures where we are using these things and all later on. And yeah, I think we'll stop here. Actually, then we'll enter into the various environments, computing environments. In these various environments, how this operating system will be, what are the objectives of the operating system and all. It varies. Suppose in case of traditional computing system, the operating system's objectives are different, and when you move on to the some other environment like mobile environment, for example, like your mobile phone, or your like a simple a laptop, not laptops and all the other thin devices and all, where the environment is different. So in that case, the operating system responsibilities also will be different. So under that, we'll try to discuss this part later on, maybe the next lecture. Another 15 minutes it may take to compute to complete this one. We'll try to expose you what are the various environments, and under those environments, what are the various objectives the operating system should handle. So with that, we'll complete this, and next we move on to the later part, like how to design an operating system and all. So that we'll discuss later. So tomorrow we'll have a class double lecture. So we'll try to see that how fast we can able to cover, because all these things are like, no, I'm also not giving you go into the details, not just giving you. I'm almost like making you to familiarize with the various terminology related to operating system at a broader perspective and all, right? And the actual things, the more detailed ones, we'll discuss later on. Maybe after another 2-3, like maybe by Thursday we may start if possible, right? So let me stop here. Yeah, let me stop the presentation and stop the recording.